What's up guys, my name is Ritvik Rustagi, and today I'm going to be teaching you everything you need to know about Unit 2 of AP Calculus AB and BC, and this is where all the fun stuff begins. It's on derivatives, and if you haven't already, please go to the description right now and get my free AP Calculus AB and BC books. Now those books have everything you need to know to get a 5 and an A in your class. So what are you waiting for? Get it immediately right now. And now, let's begin with Unit 2. So Unit 2 begins with the average rate of change. So the average rate of change is basically the rate of change for a very large interval, while an instantaneous rate of change is the rate of change for an extremely small interval, like at a very specific point. So basically, right, the average rate of change is f of b minus f of a over b minus a. So now let's move on to the limit definition of a derivative. So basically, dy over dx is the limit as h approaches 0 of f of x plus h minus f of x over h. And then the other way to do this is dy over dx equals to limit as x approaches c of f of x minus f of c over x minus c. And you should know both of these forms. I prefer the first one, and that's the one that most people in general use. And now, these three symbols you see on the right, dy over dx, y prime, and f prime of x, they all represent the derivative, right? So for example, y prime, that represents the derivative of the function y, and f prime of x represents the derivative of f of x. Now, sometimes you'll be asked to estimate derivatives of a function at a specific point. So basically, you'll be given a table like this one, and then, like this problem, it asks us to estimate t prime of 7. So basically, the rate at which the temperature changes when the distance is 7. So to approximate it, we're going to use the points that are close to 7. One to the left and one to the right. So in that case, we use x equals to 6 and x equals to 8. So we're going to find the average rate of change between those 2 points, and then we'll approximate that to the slope at x equals to 7. So basically, t of 8 minus t of 6 over 8 minus 6 is 55 minus 62 over 2, which is negative 3.5. So t prime of 7 is approximately negative 3.5. Now, when do derivatives exist and when do they not? So remember that derivatives do not exist at all points, and there are some exceptions, right? It's not going to exist at every point. So basically, if a function is not continuous, then differentiation will not be possible at that point. And then, if there is a function, right, with a vertical tangent, right, at a point, then the function will not be differentiable at that point. And then whenever there's a sharp turn, then it's not differentiable again, and the reason is that the left-hand derivative does not equal to the right-hand derivative. Now let's move on to the power rule, which basically makes differentiating very easy, because we're not going to be using the limit definition for derivative to differentiate unless a problem specifically asks us to. It's pretty rare to see that. We're going to be using these rules, which make our life very easy. So basically, you bring the exponent of n down, and you subtract 1 from the exponent, and you get n times x to the power of n minus 1 using the power rule. So let's look at some examples. The derivative of x squared, you bring the exponent of 2 down, subtract 1, you get 2x. Now the derivative of x cubed, you bring the exponent of 3 down, you subtract 1 from the exponent, and you get 3x squared. The derivative of x to the power 4, you bring the exponent of 4 down, subtract 1 from the exponent, and you get 4x cubed. Now x to the power 5, you bring the exponent of 5 down, you subtract 1 from the exponent, and you get 5x to the power of 4. So now let's go over some derivative rules. So the derivative of any constant is always 0. And if we're asked to differentiate the sum or the difference of two functions, then please differentiate each term separately and then add them or subtract them after. And this is very important. It'll make your life much easier. And if we have a constant multiplied to a function and we're asked to differentiate that, you can factor the constant out. Let's look at some examples. The derivative of 3, it's 0 because it's a constant. The derivative of negative 2, just because it's negative doesn't mean it's not a constant. It's also 0. Now the derivative of e, that's also 0 because e is a constant with a known value. The derivative of e squared, now that's also a constant with a known value. For example, e to the power of 100, that's also a constant, right? So the derivative is 0. Now the derivative of pi, that's also 0 because pi is a constant with a known value. Now, let's differentiate 2x cubed plus 5x squared plus pi. So as I said, differentiate each term separately if you want to find the derivative. So basically, we find the derivative of 2x cubed separately, 5x squared, and pi all separately. So we get 6x squared plus 10x plus 0. Now let's differentiate 6x squared minus 12 times the square root of x plus 24x cubed. Now, I can simply jump to differentiating each term, right, separately. But first, I'm going to factor the 6 out just so I can show you the example of it. So I factor the 6 out and I get the derivative of x squared minus 2 times the square root of x plus 4x cubed. And now I split each term and differentiate each term separately, and I get 6 times 2x minus 1 over square root of x plus 12x squared. Now, these are some common derivatives you should memorize. The derivative of sine of x, cosine of x, tangent of x, cotangent of x, secant of x, cosecant of x, e to the power of x, and the natural log of x. So please pause the video and memorize these. Now I'm going to be teaching you the product rule. So the product rule is basically when you're differentiating two functions multiply to each other, and you simply need to memorize this formula that the product rule is f prime of x times g of x plus f of x times g prime of x. Now let's look at some examples. So if we're asked to differentiate x squared times sine of x, then we first differentiate x squared to get 2x, and we simply multiply that to the other function, sine of x. And now we differentiate sine of x to get cosine of x, and we simply multiply to x squared. Now the derivative of e to the x times cosine of x. So we first differentiate e to the x and multiply to cosine of x. Now we add that and we differentiate cosine of x and multiply to e to the x. So we get minus sine of x times e to the x plus e to the x times cosine of x. Now for differentiating x cubed times e to the x, so we first differentiate x cubed and multiply to e to the x to get 3x squared times e to the x. Now we differentiate e to the x and multiply to x cubed. So we get plus e to the x times x cubed. Now let's go over the quotient rule, which is another formula you should simply memorize. So when we're differentiating a function like f of x over g of x, then the formula is f prime of x times g of x minus f of x times g prime of x over g of x squared. Now let's look at some examples. So if we're asked to differentiate x squared plus 1 over x minus 1, then we simply use the quotient rule. So the function at the bottom is squared. So we get x minus 1 squared, and then at the top, we first differentiate x squared plus 1, we multiply to x minus 1, minus, now we differentiate x minus 1 and multiply to x squared plus 1. Now let's differentiate 2x squared plus cubed over x squared minus 1. So we square the function at the denominator, and then at the top, we first differentiate 2x squared plus 3, we multiply that to x squared minus 1, minus, now we differentiate x squared minus 1 and we multiply that to 2x squared plus 3. Now, let's look at a free response question from an actual AP exam. So please pause the video and try the problem. So basically, in part A, we want to find the derivative of f plus g at x equals to 2. So, we know that the derivative of f of x plus g of x is simply f prime of x plus g prime of x. Because that was the rule I showed you before. You simply differentiate each term separately. So each function separately. Now we plug in 2 to get that we want to find f prime of 2 plus g prime of 2. So we simply search through the table to find each value, and we get 6 plus 7 equals 13. Part B, we want to differentiate f of x times g of x at x equals to 2. So we use the product rule, which says that the derivative is f prime of x times g of x plus f of x times g prime of x. So we substitute 2 in, and then we go through our table to find each value, and we plug that in to get 6 times pi plus 3 times 7, which is 6 pi plus 21. Now part C wants us to find the derivative, right, of f over g at x equals to 2. So we use the quotient rule, and we know that the derivative is g of x squared at the bottom, and at the top, f prime of x times g of x minus f of x times g prime of x. So we substitute 2 for x, and then we find each value such as f prime of 2, or g of 2, f of 2, and g prime of 2, and we substitute all of these values into our expression. And doing so gives us f times pi minus 3 times 7 over pi squared, which is 5 pi minus 21 over pi squared. Now, this is another free response question from an actual AP exam, so please pause the video and try it on your own. So in part A, we want to find the domain. So clearly, the denominator cannot be 0, which means x cannot be negative 2 or plus 2. So the domain is basically all values of x except negative 2 and positive 2. Now in part B, we want to find all the vertical asymptotes and the horizontal asymptotes. So the vertical asymptotes can be found by setting the denominator to 0. So x squared minus 4 equals to 0, and we get x equals to negative 2 and positive 2. Now the horizontal asymptotes are found by observing the degrees. For example, if the degree of the numerator is the same as the degree of the denominator, then the horizontal asymptote occurs at y equals to the highest coefficient, right? The term with the highest degree, the coefficient of that, over the term with the highest degree in the denominator and the coefficient of that. But in this case, the degree of the numerator is less. So simply, the horizontal asymptote occurs at y equals to 0. Now part C wants us to differentiate this function. So we use the quotient rule. And basically, at the bottom we have x squared minus 4 squared. And then at the top, we have 2 times x squared minus 4 minus 2x times 2x minus 5. And we can expand this and simplify to get minus 2x squared minus 8 plus 10x over x squared minus 4 squared. Now in part D, we want to find the equation of the tangent line to 0 comma f of 0. So let's find the y value of the point when x equals to 0. So we simply plug in 0 into f of x, and we get 5 over 4. So this means the tangent line intersects the point 0 comma 5 over 4. Now let's find the slope at the point x equals to 0. So in part C, we found an expression for f prime of x, so we plug in 0 to find that f prime of 0 is negative 1/2, and that's the slope of the tangent line. So we write the equation y equals to negative 1/2 x plus b. Now we substitute our point 0 comma 5 over 4 because we know that the tangent line must go through it, and we can solve for b to find that b, which is the y-intercept, is 5 over 4. So our final equation is y equals to negative 1/2 x plus 5 over 4. Now thank you so much for watching this video, and please don't forget to like, share, and subscribe, since that's going to tell me that you guys are truly enjoying and learning from the books and the videos that I've been making for you guys. And don't forget to join the Discord server to meet other hardworking students that are preparing for various competitions and exams such as the AP exams. And also, don't forget to follow the Instagram if you have Instagram to view educational reels and cool animations. And again, thank you so much for watching this video, and I really hope to see you soon back again on this channel.